Hello, this is Bunton with your Visual Functional Mathematics at Level 1, featuring Section 1, Numbers. Today's lesson is Lesson 5 on decimals. You will learn not all numbers are whole numbers. You will learn that decimals are less than a whole. You will also learn how to put decimals in order, how to add and subtract decimals, how to multiply and divide decimals, and how to divide decimals by using calculators. The key words and phrases for this topic are whole, decimal of course, decimal places, and rules. Rules that guide you on how to do mathematics correctly, not rules to control you. Not all numbers are whole numbers. Decimals are numbers with a decimal point like what you're seeing on the screen in them. For example, 0.5, 1.3, 0.5, and so on. Some decimals are like 1.287, 3 decimal places. What are they? They're used to show the numbers in between whole numbers. The number 3.95 is a bit smaller than number 4. The number 3.5 is exactly halfway between numbers 3 and 4. The number 3.257 is slightly bigger than 3.25. What does all this mean? One thing I want you to realize is decimal is like fraction. It is actually fraction. The only thing is the whole is divided into either 10 parts for first decimal place, 100 parts for 2 decimal places, 1,000 parts for 3 decimal places, and so on. But what does that mean? Let's take a look at this. The first digit after a decimal point shows tenths. The second digit shows hundredths. And the third digit shows thousandths. Note that I say thousandths. I emphasize the TH for you to know how to pronounce decimal places. The first digit shows tenths, the second digit shows hundredths, and the third digit shows thousandths. The following will show you the relationship between numbers of decimal places. First decimal place is over 10. For example, 1/10, 2/10, up to 9/10. The second decimal place is when you divide those decimal places from 1 to 10 decimal places in the first digit and you add a second digit. Then the second digit is in between each of the spaces between the first decimal place. And that is over 100. Example, you have 1/100th, 11/100th, 99/100th, and so on. 3 decimal places are noted as 1,000th, 0.001 is 1,000th, 0.213 is 213,000th, and 0.999 is 999,000th. So the number of decimal places have the same number of zeros. Let's go a bit further. What you see on the board are 2 number lines. The first one is drawn between 3 and 4 and is divided equally. So you have 3.1, 3.2, 3.3, 3.4, and in the middle 3.5. It continues up to 4. However, look at the point between 3.9 and 4. You will see that the arrow is pointing at 3.95. That means that 3.95 is over 100. Why? Because that gap between 3.9 and 3.4 is further split into 10. And you know that 10 times 10 is 100. We go a bit further to look at 3 decimal places. If you look at the number line at the bottom, between 3.2 and 3.3, you will see 3.21, 3.22, and then the arrow pointing at 3.23, 3.24, and then another arrow pointing at 3.25. And then between 3.25 and 3.26, at the bottom you see an arrow pointing at 3.257. So you see, as you increase the decimal places, you further split the decimals into 10 parts. And what you're seeing is where we're concentrating on. You read this 3.95 at the top not as 3.95 but 3.95. Now, once you know these decimals, you'll further understand how we put decimals in order. I'll just explain this example to you briefly. Put these decimals in order of size from smallest to largest. 1.7, 0.75, 0.758, and 0.078. First of all, put the numbers into a column lining up the decimal points as you see in step 1 below. Make all the numbers the same length by filling in extra zeros at the end as you see in step 2. Look at the numbers before the decimal point, because the numbers before the decimal point tell you that they are whole numbers. If there are zeros before the decimal point, then they are not whole numbers. So look at the numbers before the decimal points. Arrange the numbers from the smallest to the largest. That is in step 2. And then step 3, it says, if any of the digits are the same, move onto the digit after the decimal points. Arrange the numbers from smallest to largest. So there you see all these 0 point something come first before the 1.700 to differentiate between the whole numbers and just the decimals. Now, step 4 is where we put them all in order. 0.078 is 78 over 1,000. 0.750 is 550 over 1,000. 0.758 is 758 over 1,000. And then 1.700, because the 1 is a whole number, so it's bigger than the rest of them. So you begin to get the difference now and the values of these decimal points. Going back to the original problem, the order is 0.078, the smallest, followed by 0.75, followed by 0.758, and the largest is 1.7. Practice question. Which number is the larger in A, B, and C? Which number is the smallest in the pairs of A, B, and C? Just follow the example we've done and you'll be able to see them. Okay? Arrange them, make sure they have equal number of decimal places, and then you'll be able to identify the smaller from the bigger or the bigger from the smaller. Put these weights in order of size from smallest to largest. 0.63, 6.006 kilograms, 0.6 kilograms, 0.607 kilograms. Question 4 is applying decimals within the context of kilograms, as you would do in the real life. And these are the answers. Remember to pat yourself on the back if you got all of them right. If you don't worry. Just do the corrections and learn from it. Adding and subtracting decimals. You can add and subtract decimals using a calculator. Just remember to type the decimal point into the calculator. Example 1. Sarah wants to know how much she spends on lunch on a weekend. On Saturday, she spent £2.75 on a sandwich and £1.32 on a cup of coffee. On Sunday, she spent £1.60 on some soup. Note that when I'm talking about money, the decimal places are 2, and I refer to them as not 1.6 but £1.60, because it's a context when you're measuring money. How much did she spend in total on lunch this weekend? The answer? You add all of them together. Because it's money, they have equal decimal places. So 2.75 plus 1.32 plus 1.60 is equal to £5.67. And the notation at the bottom, you will see how you put them on the calculator. 2.75 plus 1.32 plus 1.60, and then you press your equal sign and it will give you. It's worth knowing that calculators always function in decimals. So bear that in mind. They will come in very useful. Adding and subtracting decimals. Example 2. Paul has been on a diet and lost some weight. He used to weigh 93.7 kilograms. He now weighs 88.4 kilograms. How much weight has he lost? The answer, you take away what Paul weighs now from what he used to weigh, which is 93.7 minus 88.4, which is equal to 5.3 kilograms. A simple, straightforward, whole number principle is applied to the subtraction, because, for example, 3 minus 8, you cannot, so you borrow from the tens column. 13 minus 8 is 5, and that is your answer. Adding and subtracting without a calculator. Write the numbers one above the other, lining up the decimal points. This is important. You have to line up the decimal points or you will get it wrong. Make sure all the numbers have the same number of decimal places by filling in extra zeros at the end where it's needed. Write a decimal point on your answer line lined up with the decimal points in the numbers above. Add up to the columns from right to left. Remember to carry digits to the next column when you get a number that is greater than 9. Adding and subtracting without a calculator, and this is the example. What is 47.3 plus 2.83? You line up your decimal points, you add zeros to those numbers with one decimal place. So you have 2 decimal places, and then you apply the principle of subtracting or adding as you would with whole numbers. And your answer is 47.3 plus 2.83 is equal to 50.13. I've added some notes. Please read them and it will help you understand further. Subtracting decimals without a calculator continues. Write the numbers one above the other with the biggest number on top, lining up the decimal points. That's the explanation. Make sure all the numbers have the same number of decimal places by filling in extra zeros at the end where needed. Write a decimal point on your answer line. Line up with the decimals in the numbers above. Subtract the number in each column from right to left. Remember to borrow when the top digit is smaller than the bottom one. This is subtracting, and this is an example. 59.8 minus 8.78. 59.8 is written down, and then the 0 is added to fill in the decimal gaps. Note that the decimal points are lined up, and then 8.78 is written as it would normally appear. And then you apply the principle you would in normal number subtraction. And your answer is 59.8 minus 8.78 is equal to 51.02. Not 51.2, but 51.02. Here are some practice questions, set 2 for you. Read it carefully and understand it. Question 1 is pretty straightforward. You have to add. Questions 2, 3 and 4 are exam type questions, so you have to read it very carefully to get it right. Jenna wants to know how much her baby daughter Lucy has grown. Lucy was 48.75 centimeters long. She is now 51.6 centimeters long. By how much has Lucy grown? Remember your rules about decimals and decimal points. Matt goes to the garden center. If he spends £20 or more, he will get a free watering can. Matt spends £12.99 on a trowel, £4.95 on a flower pot, and £1.62 on a bag of seeds. Will Matt be given a free watering can? Explain your answer. That last bit in number 4, explain your answer, is important. You need to make sure that when you're doing maths, it's not just about figures, but it's about explaining what you've done. And your answers are there for you to see. Okay? Look at it, mark your work, note what you couldn't get right, find out why you couldn't get it right, and make a correction. Let's look at multiplying and dividing decimals, and here is an example for you. You can multiply like you would a whole number, only you need to make sure you respect your decimal points and you follow the rules about multiplying, which are: Lizzie makes 1.2 kilogram of fudge. She wants to give an equal amount to 3 friends. How much fudge should each friend get? Give your answer in kilogram. This is a division sum. And what you have to do is to divide 1.2 by 3. That is pretty straightforward. Note your decimal point. Multiplying and dividing decimals, example 2. Chris is working out his petrol expenses. He has driven 63.5 miles on business this week. He is allowed to claim 30p per mile for petrol. How much money can Chris claim for petrol this week? Give your answer in pounds. The answer: Chris divides 63.5 by 0.30, which is 19.05. Now, because we're not using calculator, you will ask, how did he do it? Let's find out. Now, because we're not using calculator, you probably might ask, how did he do it with the decimal points? Let's find out now. Start by ignoring the decimal points. Just do the multiplication with whole numbers. Count the total number of digits after the decimal points in the original numbers. That is the number you want to multiply and the multiplier itself. Write the decimal points to make the answers have the same number of decimal places. That is when you're multiplying now. So, for example, 1.2 has one digit after the decimal point, and 2.45 has two digits after the decimal points. So, 1.2 times 2.45 would have 3 digits for its answer after the decimal points. And that is how we do it. An example. What is 1.06 times 1.8? Ignoring the decimal points, do the whole number multiplication. 1.06 times 18. You move the decimal points completely, which is equal to 1,908. Now, how do we work out the decimal points correctly? Count the number of digits after the decimal points. 1.06 times 1.8 has 2 plus 1 digits after the decimal point. So the answer will have 3 digits after the decimal point. Write in the decimal points to give a number with the correct number of decimal places. So 1.06 times 1.8 is equal to 1.908. If you look at the first line of the example above, you'll see that 106 times 18 is 1,908. The same number of digits, but with different values. That is because we moved the decimal at the start, just to make sure we get it right. Dividing a decimal by a whole number without a calculator. When dividing a decimal by a whole number, set the question up as you would for whole numbers. Write a decimal point on the answer line directly above the decimal point in the number you're dividing. Then do the division using the same method as for whole numbers. Let's look at the example. A zoo has a giraffe that is 5.94 meters tall and an elephant that is half as tall as the giraffe. How tall is the elephant? You have to divide 5.94 by 2. And if you look at those 3 steps at the bottom, it will show you how to do it. Okay, so 5 divided by 2 is 2. And then you have remainder 1, which you pass over to the 9. 19 divided by 2 is 9. And you have a remainder 1, you pass it over to the 4 to make it 14. 14 divided by 2 is 7. So the elephant is 2.97 meters tall. So you see that when we started with whole numbers, we are trying to get the principles of adding and subtracting, borrowing and carrying without making mistakes. And we can apply that to decimals and other measurements. Let's look at this one. Dividing a number by a decimal without a calculator. Write the division as a fraction. The number you're dividing by goes on the bottom. Multiply the top and bottom by 10 or 100 or 1,000 to remove any decimals and leave the whole number on the top and bottom. You must multiply the top and the bottom by the same thing. Do the whole number division to give the answer. Now, what does that mean? Let's look at an example to understand that better. Example 2, dividing a number by a decimal without a calculator. What is 27.6 divided by 1.2? Write the division as a fraction. 27.6 divided by 1.2. So you write it 27.6 over 1.2, that's a fraction. Then multiply the top bottom by 10 to get the equivalent fraction. And you do the same at the bottom because both top and bottom have just one decimal point. Do the whole number division. 276 divided by 12 is equal to 23. Look at the bottom there. So 27.6 divided by 1.2 is equal to 23. Remember, remove the decimal points and just divide them all like whole number. Practice question set 4. What is 1.6 times 2.67? Calculate 46.8 divided by 3. And you have question 3 as an exam type question. Brian has a 12.6 roll of wallpaper. He needs to cut it into strips that are 2.4 meters long. How many whole strips can he make? Whole strip means equal length, 2.4 meters long, each of them. He is also painting the ceiling. He has bought 3 tins of paint. Each tin of paint covers 4.75 square meters. His ceiling has an area of 15 square meters. Does Brian have enough paint? So what you have to do is you divide, and that is your answer. Question 1, 4.272. Question 2, 15.6. And question 3a is 5 rows. And then question 3b, the answer is no. He only has enough paint for 14.25 square meters. And that's our lesson. Now all you have to do is think of what we've learned, make a note of it in your own words, what you've learned, and then compare it with mine. And this is my summary. You have learned that not all numbers are whole numbers, and you've also learned how to use the number line to read the digits and their values in the decimal places. You know now that to put decimals in order, you must first arrange the decimals so they have the same number of places. You have learned to ensure we type the decimal points when using a calculator. We've learned to add decimals with and without calculators. We've learned how to multiply and divide decimals. We've learned the rules of dealing with the decimal point when multiplying 2 decimals. That's important. And that's your lesson for today. Thanks for coming. But before we go, remember that the next lesson will be on rounding. That will be a short lesson, but it will be a very important lesson because in the corporate world, rounding is